Okay, this is intermediate algebra factoring. First thing we're going to start off with here is looking at two different types of equations. One's trinomials that begin with 1 and trinomials that begin with a number greater than 1. And here the A would signify a number greater than 1. If a trinomial starts with only a 1, the 1 in front of the x squared there, it's factored normally as anything that should be factored. You would just look at the back part there where the 9 is and find out what multiplies to 9. 3 times 3 multiplies to 9, and also adds to the center. This is the normal factoring technique. So the 3 times 3 multiplies to 9, but the 3 plus 3 adds to the 6. So you get an equation here where this is your answer, x plus 3 times x plus 3. And you can check this. You can see just by checking x squared plus 3x plus 3x plus 9 gives you, if you combine terms, x squared plus 6x plus 9. Now the other way to do the other type of problem is to look at the way where the A there is going to have a number greater than 1. And it's the one that's a little trickier. So we have this problem where the 2 in the beginning is greater than 1. And there's a slightly different method to solving this problem. The original problem was a little easier to see. This is a little harder to see. The first thing you have to do is multiply the 2 and the 3. The 2 and the 3 are going to give you a 6. So the 2 times the front and times the 3 in the back is going to give you a 6. And you have to make sure of the signs. If it's a positive 2 or negative 2, it's a positive 3 or negative 3. In this case, they're both positive, so 2 times 3 is going to equal 6. Now you have to find out what's going to add to the center. And when we look through what multiplies to 6, because 2 times 3 is 6, but also adds to 7, you have 6 and 1. 6 times 1 equals 6, which is the outcome that we needed because of 2 times 3. And then 6 plus 1 adds to 7, which is the center amount. And then from this point, you just split that center apart. You split that 7 into the two lower terms that you found now, the 6 and the 1. So this is your new equation. And then from here, it's just factoring by grouping. You're just going to take the numbers that you can find out of each part, and from the front part you're going to have a 2x come out and leaving an x plus 1, and from the back part you're going to have a 1 come out leaving an x plus 3. So the front is going to be 2x plus 1 and the back is going to be x plus 3. I kind of jumped ahead on that one, but you can see there if you're taking the 2x out of the 2x squared plus 6x, and then you're also taking the 1 out of the 1x plus 3. So then the 2x plus 1 becomes your first factor, and then the x plus 3 becomes your second factor. So it's a little more complicated when the lead coefficient is greater than 2, but that's how it's done. We have a problem here like this. This problem is going to show you how to work with the negative. Negatives are a little trickier whenever you're trying to do the factoring by grouping, but you still do the same thing. It would be 3 times negative 3. So 3 times negative 3 is going to give us a negative 9, and I wrote there on the right it's what multiplies to negative 9. And again, remember the signs do count. Signs don't always count in all types of parts of this, but in this case it does. So you need to define what multiplies to 9 and what adds to 8. So in this situation, you have to split the center with two things that added to 8. We have to find that it was a positive 9, but a negative 1. So the 3 times 3 times negative 3 gave you a negative 9, but positive 9 minus 1 gave you a positive 8. And here we have it like that, splitting the center again, 9x minus 1x. Now again, we're going to do the factoring by grouping. You just take out from the first half and then take out from the second half. Now here is a little bit of the trickier part. In the front, the 3x comes out, leaving an x plus 3. And if you can check and make sure, so it's 3x times x is 3x squared, and 3x times 3 is 9x. But in the back, it's a little bit harder to see, but it has to be a -1 that comes out, because you want to leave an x plus 3 in there so that the front one and the back one are identical. So when you take a -1 out, you can check it. -1 times x is -1x, and -1 times 3 is -3. And then you move on down, and you're going to group these again. Here you want to combine the x plus 3's, the two times that they show up as one term, x plus 3. And then the ones in the front is the 3x minus 1 becomes one factor also. We're going to move on to the next problem here. There's sometimes, this is going to show you on how to manage the negatives. It's a little challenging sometimes to know how to handle the negatives. In this instance, you have the -4 coming out of the -8 and coming out of the 4 in the front. But to make sure that you've done it right, you have to check it. You have to see on how they line up. It doesn't always seem easy to see. So the -4x times the 2x will give you the -8x squared. And then check the back. The -4x times the -1 gives you a positive 4x. It's easy to get that mixed up or crossed. But whenever you multiply back through and you distribute and you check it, the bottom should be the same as the top. Here we have a slightly different problem. If you want to factor when you have a degree 4 trinomial, you just have to look at it as the difference of two squares. So you're going to have an x squared minus 1, x squared plus 1. And you see that it has to be a -1 and a +1, because that's what's going to give you the -1. And then from that, you have to realize that the x squared times the x squared is what is necessary to have the x to the 4th. So you split that x to the 4th in half into 2x squareds. But you have to also notice that x squared minus 1 is a difference of two squares. So that's going to reduce down to x minus 1, x plus 1. In the original, in the middle there, the x squared plus 1, it's prime. It's just going to come straight down. There's nothing else that can be done with that. That x squared plus 1 just comes down to the last part of the equation, and there's nothing more that can be done. But in this form, the x squared plus 1, x minus 1, x plus 1 is reduced as far as it can go. This one right here is a little trickier. A lot of people will try to do this. Now, this is the warning. This is what not to do. This x squared plus 1 is done. A lot of people will try to do this part. Take the x plus 1 times x plus 1. But this is what I want to show you. This creates more of a problem. It makes the problem bigger. It doesn't make it smaller. And you can see that in the middle there, when you're doing foiling, you're going to get more x's. You're not going to make anything smaller, so this actually creates a bigger problem. And it's not the same thing.